Hello, and welcome to Secondhand Global Reactions. Today, an AI broke a math conjecture that had stood for 87 years, and we ask whose job discovery is now. First, what happened in one breath? In the early hours of July 20th, 2026, a short post appeared on X saying the Jacobian Conjecture is false. The Jacobian Conjecture is a math problem that nobody in the world had solved since 1939, 87 years. It fell because of a single answer produced by an AI, and mathematicians around the world confirmed within hours that the answer was real. An AI has surpassed humans. That is the kind of headline this invites, but look at the details and it is not that simple. There are 3 questions worth holding on to. 1. Why did a problem that resisted for 87 years fall in a single night? 2. How true is the phrase, an AI solved it? 3. From here on, whose job is discovery? Let's take them in order. Let's take it in order. Start with the post that became a legend. It went out in the middle of the Football World Cup final, Spain against Argentina. The poster was the mathematician Levent Alpoj, and the wording was almost absurdly casual. Hello there, the Jacobian conjecture is false, thanks. That post is reported to have passed 20 million views. For the ending of an 87-year problem, it was an extraordinarily light entrance. What was shown was not a proof of the conjecture, it was a counterexample, a single concrete case showing the claim is wrong. An example that could not possibly exist if the conjecture were true was actually built. That settles it. In 3 dimensions and above, in every case, the conjecture is false. But the 2-dimensional case, which is where most of the interest was in the first place, is still unsolved. A formal paper and peer review by specialists are both still ahead. Here is the part that matters most. Who did what? This discovery split into 3 roles. The idea that an AI might be able to produce a counterexample to this particular problem came from Akil Matthew, a professor at the University of Chicago. The counterexample itself was produced by Anthropic's AI model, Claude Fable 5. And the person who checked that answer and announced it to the world was Alpoj, from the post we just mentioned. One note, how many attempts it took the AI to get there has not been made public. Let's explain what the Jacobian conjecture says, with no equations at all. Picture a rubber sheet. You stretch it and squeeze it, reshaping it. This conjecture is about exactly that kind of reshaping, the kind you can write down as a formula. Now suppose that wherever you put a magnifying glass on the sheet, nothing is crushed flat and nothing is turned inside out. Then, the claim goes, the sheet as a whole never folds back over itself either, and the reshaping can always be undone perfectly. That is the Jacobian conjecture. Intuitively, it sounds right. So why did 87 years not settle it? To prove it true, you have to show it holds for every conceivable reshaping, with no exceptions. And there are infinitely many of them. There was partial progress, but never enough to cover the whole thing. A famous mathematician listed it among the problems for the next century, and more than 5 wrong proofs of it were actually published over the years. On the other side, showing the claim is wrong works completely differently. Whether a counterexample is real can be checked by anyone. You put numbers into the formula and do the arithmetic. Proving it is brutally hard, but checking the evidence that it's wrong is easy. That gap is why mathematicians worldwide could confirm this within hours of the announcement. On top of that, the argument was rewritten in a form a computer can read, and checked by a system that goes through a proof line by machine. That system is called lean. It is the strictest kind of checking there is, because it does not depend on any human assuming anything. Now how Reddit reacted. 2 very different communities lit up on the same day, r/math, where working mathematicians gather, and r/singularity, where people who follow AI, progress, gather. We start with r/math, where the shock was written down plainly. Machines are already better than every human at some things, just not at all of them yet. It's probably unavoidable that our field dies within a few years. I'm genuinely crying. I gave decades of my life to this. That was a researcher speaking without a filter. At the same time, the cool-headed checking started immediately. Report after report said the same thing. I verified it by hand in a few minutes. The answer turned out to be a surprisingly simple formula, with single-digit whole numbers as its coefficients, which is exactly why people were baffled. If it is this simple, why had nobody found it with a plain computer search before now? There was also a technical objection. The underlying construction appears in a 1999 paper by Vitushkin, so claiming this is brand new is misleading. Not pure applause, then. Verification and appraisal running at the same time, a very mathematical way to react. And then the conversation moved to jobs and money. The reply to the person who said they were crying went like this: "What worries me is whether society will keep paying professional mathematicians a salary at all." Another comment: "An AI has no job and no weekends. It doesn't care that today is Friday." And to the suggestion that we should just let an AI grind through every open problem, someone gave the practical answer: who is paying the API bill? This is a different order of cost from the days when you could run a calculation overnight on the university's own machines. Now for the core of this video. Why did mathematics, supposedly creativity's last stronghold, move first? The key is not how hard it is to have the idea. It is how easy it is to check the answer. AI output comes mixed with mistakes, things that look right and simply are not. That happens routinely. But mathematics is one of the rare fields where an answer, once produced, can be checked rigorously by calculation or by machine. If the generating side is unreliable but the checking side is solid, only the real results survive. That is why math moved first. And humans shaped the problem, and humans built the checking systems. So what is actually running here is not AI versus humans. It is a team, mathematicians and AI, and the machinery of verification together. That is how we read it. In fact, AI and mathematics is a subject that changed character within a single year. In the autumn of 2025, an announcement that an AI had solved 10 open problems turned out to be overstated, drew a backlash, and was withdrawn. What the AI had actually done was find already published papers that solved them. But through 2026, results that properly passed verification by mathematicians started arriving one after another. The most telling detail: the mathematician who publicly criticized the overstatement in 2025 joined a verification team as a co-author in 2026. The skeptic moved to the checking side. That is a sign the subject has become real. Here is the thing to take away from this video. Next time you see a headline saying an AI solved something, size it up with two questions. Question 1. What part did the AI actually do? Did it only look up existing papers? Did it produce a hint or a counterexample for a problem a human had chosen? Or did it pick the problem itself? Same phrase. An AI solved it. Completely different meanings. Question 2. How far has the answer been verified? Is it a candidate that just came out? Have specialists rechecked it? Has it been through peer review? Or through a machine checking it line by line? For the Jacobian conjecture, the position is this: a human chose the problem, the AI produced the answer, the recheck and the machine check are done, and peer review is still ahead. These two questions work on AI news in general, not just on mathematics. And discovery is starting to come with a price tag. In another AI company's report, the cost of having an AI solve an open problem was put at a few $100s per problem successfully solved. Once there is a price, behavior changes. Before you publish, have an AI hunt for holes in your own conjecture. That kind of use is on its way to becoming ordinary daily work. There is a limit that gets overlooked, though. In that same effort, the success rate was 9 problems out of 353, about 2.5%. So what grows is not only answers, but a pile of candidates waiting to be checked. The faster the generating gets, the more the scarce thing becomes the time of the specialists who verify. This shift has an encouraging side, and a side worth watching. The encouraging side is the widening door. A 23-year-old with no graduate training typed a problem statement into an AI and contributed to solving something that had been open for 60 years. But it was specialists who turned that rough output into real mathematics. So no, this does not mean anyone can now be a researcher. The side to watch is concentration at the base. The model itself, the computing power, and the record of how many attempts were made all sit with the companies. For this counterexample too, the exchange that led to the answer has not been published. On the other hand, there is a move to publish verification results in a form anyone can check for themselves. Whether that openness continues is one thing to watch. So is discovery a machine's job now? Look at the two ends of the process. And not yet. This time, a mathematician decided which problem to aim at, and mathematicians were the ones who certified that the answer was real. The person most central to building up that line-by-line machine checking welcomed this result, and also noted that the questions an AI comes up with on its own stay either boring or obvious. And to say an AI has surpassed humans, you would need a comparison on the same problem under the same conditions. That material does not exist. We do not know how many attempts it took, or how far a human steered it, because none of that has been published. Even so, when a celebrated mathematician says, "This is the first time an AI has solved a problem big enough that he knew its name," we think that shift is substantive. 3 things to watch from here. First, whether this counterexample passes formal peer review. Sorting out its relationship to that 1999 paper will be part of that. Second, whether the day comes when AI also takes over the problem choosing that humans still hold. Third, whether records of attempts keep being published and whether computing power keeps being offered to research institutions. That is how we measure whether the means of discovery stay in a few hands. Time to wrap up. The Industrial Revolution moved human muscle to machines. The Information Revolution moved calculation to machines. What is happening in mathematics in 2026 may be an example of part of the work of discovery beginning to move to machines as well. And still, this time, it was a human who decided what was worth asking. When discoveries get cheap, the expensive thing is the ability to choose a question and judge what its answer means. Finally, the takeaway one more time. Next time you see a headline saying, "An A, I solved something," remember the 2 questions. What part did the AI actually do, and how far has the answer been verified? Just asking those 2 lets you weigh the news for yourself. The full analysis and more reactions are on our blog, Secondhand. The link is in the description. Thanks for watching.